I wrote. I saw that the endpoint was reached. My chemistry lab professor crossed out I saw. We were titrating an unknown solution, adding drops of base until the phenolphthalein indicator turned the liquid from clear to pink. A change only the eye could catch, and yet I saw was the first thing she crossed out. The correction was matter of fact, the way a teacher fixes a spelling error. By the third lab report, I was writing that way by default. It was just science. That same semester, a different class had a conflicting rule. My writing professor told us to use the first person. It was, she explained, a matter of rhetoric. She wanted readers to see our thinking and our presence. Two conventions, two opposite assumptions about whether the writer should exist on the page at all. My classmates in both classes followed their respective rules. No one asked why. The difference between those two classrooms points to a fundamental divide. A screenwriter's personal style is what keeps audiences coming back. A novelist's voice is what readers return for. In those cases, the writer's identity is not incidental to the work. It is the work. Science goes the other way. Science assumes that nature is objective. Objectivity implies consistent laws and therefore replicability. Results determined by nature, not by the scientist. If that is true, then who ran the procedure should not matter, and the writing should reflect that. A blurred third person, a passive voice, a style that could, in principle, have come from anyone. A text that sounds like no one in particular wrote it. The logic seems to hold, but encountering a competing writing convention made me realize this isn't a law of nature, it's a deliberate choice, and a 2002 paper by Ken Hyland makes that unmistakably clear. Hyland analyzed 240 journal articles across 8 disciplines, counting every appearance of first-person pronouns. The results were striking. Mechanical engineering, 2.6 uses per paper. Electronic engineering, 11.6. Biology, 15.5. Philosophy, 34.5. And marketing, the highest of all 8 fields, 38.2 uses per paper. The gap between mechanical engineering and marketing is a factor of nearly 15. The easy explanation is that marketers simply care less about objectivity than engineers do. But Hyland's explanation is different. Different disciplines have developed different norms for how the author should appear. Writers in hard sciences adopt a less personal style to help strengthen an impression of objectivity. An impression of objectivity, not objectivity itself. In softer fields, a personal voice helps promote an impression of confidence and authority. The author's choice to appear or disappear in a text works to create a plausible academic identity within a given community. Hyland's title says it directly. Options of Identity in Academic Writing. The key word is options. The rule I felt I had to follow in the chemistry lab is, in the bigger picture, a choice on a menu. Beyond pronouns, the impersonal style also takes the form of a rigid structural convention. Introduction, methods, results, discussion. The IMRaD format, now followed by virtually every scientific paper. But Neil Lerner, Director of Communications Training at MIT, conducted archival research at Dartmouth, Amherst, and MIT that reveals how this format became standard, and why. The format did not prevail for pedagogical reasons. As science and engineering expanded in universities during the late 19th and early 20th centuries, growing class sizes and overstretched faculty pushed institutions toward grading students on content and format. By 1925, MIT's Department of Mining and Metallurgy was telling students that reports would be marked not only upon the material which they contain, but also upon the way in which the reports are written. Reasoning and judgment are hard to assess at scale. Content and format aren't. Among Lerner's archival evidence, a chemistry laboratory notebook from Dartmouth's early 20th century curriculum, where the page is divided into columns for apparatus, procedure, and observations, before any experiment had even begun. The student's role was predetermined. Anonymous middleman between observation and conclusion. The IMRaD format was born at a specific historical moment. Treating it as an inherent trait of science creates a circular justification. The format is followed because it is scientific, and it is scientific because it is followed. But if excluding reasoning and judgment was a matter of administrative convenience, it raises a deeper question, whether these elements can ever actually be erased from science. Priyan Dias, drawing on philosopher Michael Polanyi, argues that scientific knowledge inherently contains what Polanyi called an unspecifiable tacit element, supplied by the scientist's background, imagination, and skill. Polanyi uses a striking image, just as a stick becomes an extension of a blind man's arm when he uses it to explore a cave. A scientific theory is internalized by a scientist when making new discoveries. The scientist no longer attends to the theory, it becomes a medium through which they see. I can describe exactly which samples were analyzed in my chemistry lab, which instruments were used, but I cannot write down the underlying judgment, which data peaks are significant and which are just noise, which of several possible interpretations is worth developing. Over an academic career, which research questions seem worth years of investigation, and which do not. That kind of discernment is built through years of practice. It's deeply personal. The methods section in a paper can never fully contain it. The passive voice can erase the scientist from the text, but not from the judgment. If the authorship cannot actually be eliminated from science, then the convention that pretends otherwise comes at a cost. Donna Haraway, in her book Modest Witness, identifies that cost as a distorting power. Scientists, Haraway writes, see themselves as the legitimate and authorized ventriloquist for the object world. They claim to erase their personal opinions and biasing embodiment from their observation. The physical world becomes the dummy. The scientist speaks for it, yet it appears to speak for itself. Haraway traces this modesty back to Robert Boyle's experimental philosophy in Restoration England. Writing itself served as what she calls a literary technology, a tool that made experimental outcomes known to those who were not direct witnesses. It was how claims became facts, and with this came a specific assertion of power. It is not I who say this, it is the machine. The passive voice is the grammar of that assertion. Boyle's so-called open laboratory was in fact a public space with restricted access. Servants and artisans who operated the instruments were present in the room, but invisible in the paper. Boyle spoke for them and transformed their labor into his truth. The convention persists because it naturalizes this social hierarchy as a neutral technicality. I corrected and submitted that lab report, apparatus, methods, results, discussion, all in the passive voice. No one who read it would know my initial hesitation. Any trace of it had been polished away into something that felt inevitable, written as if by no one in particular. The one who writes the endpoint was reached is not thinking more objectively than one who writes I saw that the endpoint was reached. The former is just following a convention that has become old enough to look like the nature of science itself. This is how conventions gain their power. They no longer appear as choices, but as what the thing simply is. Writing as if no one wrote it actually requires a very active writer behind it. The passive voice can never erase such knowledge. It only hides the person who possesses it. To write scientifically is to perform this trick very fluently. To read science is to recognize the person and the labor behind the page.